So what is the better fuel, diesel or gasoline? Diesel and gasoline can be quantified in terms of performance and fuel economy. So some background, in the United States, the most important source of energy is gasoline, and market demand requires that 50% of each barrel of petroleum fed to a refinery needs to be converted to gasoline. This is not the same situation worldwide due to the so-called dieselization of the vehicle fleet. In some nations, mainly Europe, half or more than half of vehicles contain diesel engines. So what is gasoline? Gasoline is the first distillation product from petroleum fractions that is liquid at ambient conditions. This is also known as straight-run gasoline and typically contains carbon chain lengths of 4 to 12. At best, most oils produce around 20% gasoline from distillation. Gasoline quality is also defined by octane rating, which affects compression ratio. The higher the octane rating, the better the compression ratio. Gasoline has poor combustion performance in modern engines due to low octane ratings. This causes problems which need increasing factors of quantity and quality of gasoline during refining. Modern diesel engines operate on a middle distillate fuel because its boiling range is intermediate between gasoline and naphtha. Several grades of diesel fuel are normally marketed, defined by at which 95% of the fuel has been distilled. Higher boiling ranges indicate that there are larger molecules present in diesel fuel. Diesel fuel contains alkanes up to iocene and aromatics large as alkylated naphthalene. Diesel fuel quality is often based on cetane rating and is desired to be approximately around 50. Cetane rating can be seen as inversely proportional to octane rating. So performance, the dominant use for gasoline is as fuel for automobiles and light trucks. Most gasoline engines run on the 4-stroke Otto cycle. There are 4 stages to the Otto cycle, which are intake, compression, ignition, and exhaust. The compression ratio represents the ability of the fuel-air mixture to be compressed and is a key factor in determining performance. Gasoline has a compression ratio typically of 8 to 1 or 10 to 1. Diesel engines run on a similar cycle compared to the Otto cycle. However, diesel engines provide higher compression ratios than gasoline, up to 25 to 1, which as you can see is much higher than that of gasoline, therefore increasing its overall performance. The higher the compression ratio, the higher the pressure in the cylinder and the hotter the air, which as you can see increases the performance of the vehicle. Transportation needs are not often limited by weight of fuel, but by volume of fuel. In terms of fuel chemistry, volume is the more important parameter. Gasoline has more calorific value on a mass basis, but diesel is better on a volume basis. The density is related to volume as well and is greater in that of diesel than it is in gasoline. Therefore, diesel has a higher calorific value per unit volume at 39 megajoules per liter compared to gasoline at 35 megajoules per liter. So this directly relates to fuel economy. The result of diesel's fuel superiority leads to a 33% higher fuel economy than that of gasoline. This means that for every 30 miles achieved by gasoline, 40 miles will be achieved by diesel. Although diesel is around 20 cents more expensive per gallon than gasoline, this is negligible due to the fact of diesel's fuel economy. There are also reports that say that diesel cars are $700 more expensive than gasoline cars on average. However, this is also made up for by diesel's superior fuel economy. So why is gasoline still the tradition in the United States? Well, it comes down to EPA standards. Strict regulations have been imposed in the United States and Europe due to hazardous emissions. However, the United States has higher regulations than the rest of the world. Diesel can be a dirty fuel and lead to high productions of sulfur dioxide and nitrous oxides. Higher density fuel contains more aromatic compounds. Aromatic compounds are carcinogens, which may lead to cancer with chronic exposure. In particular, benzene has been linked to leukemia. Aromatic compounds are also large precursors to soup formation and may contain sulfur that is hard to treat. Therefore, methods like hydrodesulfurization is required to desulfurize the diesel fuel. The problem is that hydrogen is an expensive element and in return can be costly to remove the sulfur. This leads to the negation of some of the economic benefits of diesel fuel. So for the future, United States demand for gasoline has decreased since 2007, but diesel has remained constant or even increased. Diesel fuel in the United States mainly powers buses, trains, trucks, and farm equipment. However, there has been significant increases in passenger vehicles powered by diesel. U.S. clean diesel sales have increased by 25.6%, which is doubling the amount of auto markets increase. The overall increase in diesel market may lead to future changes within the United States. Diesel fuel has the potential to replace gasoline as the tradition for fuel source and vehicles in the United States. So overall, diesel fuel can be seen as the better fuel, economical fuel. But I'll let you decide which you think is better. Thanks.